worksheet. Let's take a look at the different functionality that is provided associated with chance of success. Let's go to the historical chance with beta function, and let me zoom in a little bit and take a look at this. And there is this upper section in here which allows you to start to understand based upon some number of successes and failures in a play that you may be pursuing. You can get a sense as to what is the range of average chance of success that would be represented by those numbers of successes and failures. As we need to remember that there is uncertainty associated with a piece of G in these wells, simply because it's the success or failure is a random sample associated with those number of wells. So here in this particular example, where I have a total of 20 wells that have been drilled, 4 of which are geologic successes and 16 of which are dry holes, then the chart over on the right is showing to you that this could actually occur from a wide range of piece of G values. So from a P90 to a P10 perspective, this result of 4 out of 20 wells being successful could have an average piece of G of sorry, I'm on the wrong one. Apologize. Let me go here and take a look at the piece of G value. I was looking at a particular component in there. So let me reverse back to the piece of G. So here you can see that with the 4 and the 16, that the P90 can range from 12% up to 35%, with the mode, of course, very simply would be represented by an average piece of G of 20%. But surprisingly, a wide range of chance which can actually contribute to this. Now, this beta distribution is very much a function of the number of samples that are within the number of wells that are being looked at. So, for example, if we had 200 wells that we were going to take a look at, and let's change this to 40 successes with 160 dry holes for a total of 2 wells, you can see that the beta distribution is much better defined simply because of the number of samples that you have within that particular population, such that the P10 P90 ratio is 24 to 17. So a narrower uncertainty than what we were observing previously. If you're going out into a play where there are very few tests, let's say there's 1 success and 4 dry holes, you can see that the range of uncertainty associated with a chance of success that could have resulted in that particular outcome is extremely wide. So the total number of samples is very much a driver as to the range of uncertainty that would be viewed for a piece of G. Let me zoom back out, and let's go back to the original inputs that I had, the 4 and the 16. The reason why I wanted to focus on and go back to those original values is that there is a second function in here which allows you to represent for these 16 dry holes, if you can identify what was the reason for failure that caused the dry hole. For example, there was one that was attributed to source, 2 failures for migration, etc., going on down, then you can take a look at what is the range, the predicted piece of G associated with each of those components. That's graphed up down below with the base being representative of the P90, the top of the yellow is the P10 range, but you can go in and you can investigate these so that we could look at the source with only one failure is a very high probability of success with a fairly narrow range of uncertainty, whereas you could take a look at other distributions. Here's reservoir and here's containment, where the most number of failures were attributed to, and you can see the wide range of uncertainty associated with that. So each of the components in the overall piece of G is graphed up from high to low in the lower left chart, and there's a histogram associated with the number of failures and the reason for failures associated with each of the components in the lower right chart. Next, there is a team piece of G assessment worksheet, which allows you, if you use a team process of gathering independent views as to what is the likelihood associated with the chance for each of the individual components. Here you can go in and capture that information and very easily are presented with, here in this particular example, I've got 9 different folks, each of which have input their interpretation as to what is the chance associated with the source, the migration, the reservoir, etc. And their in the green cell as the product would represent their overall chance of success. To the right in here in these green cells, we're reporting for each of the components and for the piece of G overall, what are the mean, the P50, the mode, and the min and the max associated with each of those. Of course, what we teach in the 5-day is that when you have a wide disparity between estimates for a particular component. Here in this example, there was one person who saw the probability of source as low as 55, one as high as 80%. You really need to have these folks describe why they are seeing such different functionality or different representations as to what is the likelihood of the source associated with that, and hopefully they can modify their estimates based upon information that they may not have understood. And then finally, you can, when you come up with a team consensus after you've gone through the whole process and possibly modified the initial estimates with a final assessment, you can come up with and represent what is the final team assessment in here. So this chart just allows you to record and have the conversation about piece of G. Next is an uncertainty index matrix. You may remember that the uncertainty index allows you to have an understanding about the components that are contributing to chance of success, and it's looking specifically on the x-axis. We're looking at the lowest probability of the multiple components contributing to the piece of G. So here it's ranging from 5 to 100%. The y-axis is representative of the second lowest chance of success in that, and you can go in and calculate an uncertainty index associated with that using this formula in here. So you can capture here is the lowest value and the second lowest value, and it calculates the uncertainty index. If you have an uncertainty index that is less than 0, then that is indicative that there is possibly non-coincidence associated with those factors, and it's raising a red flag that says the likelihood of you having success in this with this particular combination of inputs is much lower than maybe the multiplied product associated with the piece of G. So there are many studies by many different companies, and when you have 2 two components on a particular prospect that are less than 50%, the likelihood of a success is much, much lower. And in fact, for many companies, you actually have near zero success in those particular populations. So if you had a prospect that had a 0.3 and a 0.4, a very negative uncertainty index is citing that there's a problem in here. If the next highest was a 0.8, then what you can see is that the uncertainty index, when it's calculated, is not in negative territory, so it's a less of a problematic less of a problem associated with this particular assessment of chance of success for the prospect.